Okay, so it's great to be able to create one's own experiment, but then one's own experiment produces data from one's own experiment. And there's the question of what one does and how one teaches a relatively efficient pipeline for making something of that data to students at all different stages of their education. And part of the idea of TELLab is to make it possible for students at all levels, all the way down to intro psych and potentially down to high school or possibly earlier, to create experiments. And an important problem that arises is sort of a catch-22 between statistics and do you teach them, how do you teach them to work with data before they know statistics, and how do you teach them statistics before they know data? And data visualization has been a very effective way to get out of that catch-22. So these slides here are at bit.ly Wilmer_VSS 2020 TELLab, and that bit.ly link will be on all of my pages, so you can write it down at your leisure. I'll also plan on posting a bunch of other things, like potentially the video or other slides there. So, okay, so if we think of a simple data pipeline that a relatively novice student could use, we have TELLab, we download the data from TELLab, we get it into a spreadsheet, Google Sheets or Microsoft Excel. Then ideally, the simplest thing would probably be to copy paste directly out of the spreadsheet into some sort of a app that would do something good. Ideally, that app would be would work cross-platform, would not require a really good computer, and would work. So a browser-based tool is a fantastic thing to have. So the ability to copy paste into a browser-based graphing app that can visualize and do some simple analyses of one's data is super useful, and I found it works really well even with folks who've never done anything with data before. And for submitting the student's homework, then putting the resulting, being able to download a nice graph and put it into Google Slides or PowerPoint and submit that as their homework with a little explanation works really well. So Justin has done this, and Ken has done this, and I've done this, and other TELLab using folks have done this. So that's sort of the whole pipeline. I'm just going to talk a little bit about this part, and then getting, and then that part right there. Okay, so to download data from TELLab, you get to a screen that looks like this. You click on the little icon that looks like that or that. Those are the two experiments that we just were doing. Then you go to a screen that looks like this and says you can download the last record or all the records or a certain subset of the records in either wide format or long format. So Justin talked briefly about this. Let's expand this just a bit. So wide format is participants as rows, or par format. Each row is a participant's data and each column is a trial. Long format, what TELLab calls long format, is trials as rows, or TAR format, where every row is a trial. So here we have a very simple wide format for the experiment that we were just looking at with Justin. The MOT experiment that has 3 trials. First trial has 3 dots moving slowly, second one has 4 dots moving at medium speed, and the third one has 5 dots moving fast. We're looking here at error data. And here we have the participant ID, because this is wide format, participants as rows. So each row is going to be a participant, so sort of a long string, randomly generated string of that participant's ID. We have a little label that says it's MOT, we have a label that says this is error data, and we can have 0 errors on a trial or more than 0, 1 or 2 or up to 5 on this trial right here. So if we expand this out a little bit, there's another subject, there's a whole bunch of subjects, and we can zoom back a little bit, and then we can add more trials, and that's how the data would scale with that. One thing I absolutely love about this form of data is you can have your eyeball on a huge amount of your data set all at once, especially if you zoom back a little bit in Excel or Sheets. And then you can use conditional formatting to color the data, and at a glance, you can get a really fantastic sense of the data. And novice students find this very easy and very illuminating to think in a really detailed way. You know, there's a sense in which it's very intuitive to think about individual trials, because that's the thing that people have actually seen. Once you get to means and medians and stuff, that starts to confuse a lot of novice students. But being able to operate on the individual trial level is really has an intuitiveness to it. So if we were to conditionally format this data right here, we would see that actually this is only one participant's data, or actually 5 participants' data on 3 trials, and I copy pasted it a bunch of times. So conditional formatting is also great for a professor to identify fraud in student data collection, but of course that never happens. Okay, so anyway, wide format is good for seeing data. Here we have one participant right here, all of their data in wide format. We can look at that in long format too. Here's one trial per row. We repeat the participant ID again and again and again, and we have all the trials. And in both formats, we stack the data vertically. So here's the second participant over in wide form. Here's the second participant in long form. You can probably tell that very quickly you can only see one participant's data, or even only a small subset of one participant's data in long form. So it's not great for looking at the data, but it's pretty good for understanding the trial by trial experience. And especially if there's randomization involved, it can really help students to gain intuitions for, that happened first and second and third. And also a lot of data manipulation is much easier to do with long format. Again, especially if there's randomization. Okay, so we get the data in that form. Maybe we compute some summary statistics by summing rows, or you know, a few carefully chosen sheets or Excel formulas, or with long format, often using what's called a pivot table, which is super useful. And then let's copy paste the data. Say we have one row per participant and some sort of summary score, for example. And let's paste it into some sort of an app. Now,
hey, Jeremy, can I interrupt?
Yeah.
Do you want to just show, go through that process for the MOT data that we just produced?
So I was having that as one option, but I think only a few folks managed to get through to the finishing the MOT stage. When I checked a couple minutes ago, it was just 5 folks.
Okay, sorry for the interruption.
So yeah, I'm going to use a slightly canned data set, but hopefully of some interest to folks. So a few years ago when I was teaching a lot of intro psych, I got frustrated with how difficult it was, even in Excel or Sheets, to get from the point of having some nice data to getting a nice graph. There's just 30, 40, 50 clicks that one would have to do every time one wanted to create a graph again. So I programmed up a website called Show My Data. It's a bunch of free web apps, copy paste your data right in, and they immediately give you a best practice data visualization with carefully chosen defaults. You can change a bunch of parameters if you like, and get a high resolution download that's suitable for publication or presentation. So there are a bunch of other great options out there for doing something pretty similar, where you can just copy paste your data in, free things or free attachments to corporate things in some cases.
Could I bust in here a little bit?
Yeah.
So yeah, I think Jeremy's gone way beyond what I've done as a teacher. And I guess I'm kind of interested in just I have a sort of data visualization is very important to me, and statistics are less important. I want the students to really look at their data, and that Jeremy's certainly doing that. But I guess I'm a big fan of Excel for one reason, is I want students to hand in their homework, and I want them to make graphs, and I want them to present me with a PowerPoint file and their graphs. One interesting thing, I'm not sure if Sheets does this, if they hand in a graph and you click on a data point or an error bar, it'll actually bring you to the Excel file that the student used to all kinds of mistakes. So I really feel I don't know if these other things, but I really found it as an error checking, because most students, when they do lab reports, you really can't check whether they've done it right. And I think this is, I'm a stickler for accuracy. I don't want students to just slough around. And so it's really important that they understand. I mean, I don't know, the students I've had at Harvard, they're very fast with their fingers. And I found that they just come up with little numbers and all of a sudden they put them on a graph. And I just don't want people to do that. I just feel very uncomfortable. I really feel people have to be quite deliberate. That's just my thing. Jeremy, that's okay.
One thing from the instructor's perspective that I love about data visualization is that I can, in about a half a second, notice a lot of errors that students make just by looking at their graphs. And then, yes, if they've submitted their data also, then I can take a look back for those graphs that don't look good. I can look at their data. So it actually makes grading an order of magnitude more quick than it used to be when students would submit their work in other ways. So the sort of underlying philosophy of Show My Data is to show the data, as one might guess. There was a famous data visualization fellow named Edward Tufte who was a big proponent of this in 1983, but the technology took about four decades to catch up to him in many ways. Just my favorite demo of why to show the data. So here's a couple data sets plotted X, Y, and they all have the same mean X, and they all have the same mean Y. They all have the same standard deviation, X and Y, and the same correlation. So here we go. Someone had a lot of fun creating these data sets. And my 9-year-old's favorite one of all is that one right there. So yeah, looking at the data and looking at it on an individual participant basis is just such, as Ken says, error checking. That's a fantastic way to check errors. So I'm going to do a quick demo here of Show My Data with one of my favorite demo data sets, which shows minimum temperatures. I do this partly out of some masochistic Boston interest in drowning in misery. So have here a year's worth from 2018 of minimum daily temperatures, starting in January 1st, January 2nd, January 3rd, for both Boston and Honolulu. So let's grab this Boston and Honolulu data and let's wallow in our sadness about how they differ. First, we're going to go to a histogram app. So sort of independent groups, sort of an analysis here. Okay, so I just copied that and I paste it here. And there we go. That took about 2 seconds. We can see Honolulu is warmer than Boston. We can see that Boston gets really cold, but it also gets really hot. And we can, after we get over our misery or decide to buy some plane tickets, we can play around with various parameters. We can make the dots bigger. We can jitter them a little bit. We can make them less opaque. We can make them solid. We can add quantiles. So we get mean, median, 25th and 75th percentiles there and there. And this is my favorite graph to show first because, we talk a little bit about this, we talk through it, and then through some careful shaping of question and answer, I get the students to realize that there's something this graph doesn't tell us, which is which days up here are linked to which days down there. And when they realize that, this is a moment of insight. They're like, oh my gosh, no, yeah, I really want to know that. So sometimes we'll talk about, are there any days in Boston? Does Boston ever get warmer than Honolulu? So we can answer that question by going to our repeated measures app over here and pasting in our data. So we have Boston temperatures over here. We have Honolulu temperatures over here. Each dot is a day. And this line here is the line that shows all of the same temperatures in both places, 0, 0, 20, 20, 40, 40. And we can see that there actually are no days where Boston is ever warmer than Honolulu. So we have a nice introduction, within 2 seconds, no logistical challenges, just straight to the insight of what the difference is between independent groups and repeated measures. And then on a similar, as long as we have a graph like this, we can ask the question of, is there a correlation between these two things? So we can have a sort of similar graph, but just scaling the axes carefully. And then we can look at the correlation between Boston temperatures and Honolulu temperatures. And what was being hidden here, of course, is that both places are in the Northern Hemisphere. So when it's warmer in Boston, it does tend to be warmer in Honolulu.